Professor Bialis here. In this video we're going to be talking about section 9.2 where we have absolute value equations. Okay, an equation is an expression equals another expression, but in this case we're going to have absolute values involved. Really what's important with this is the initial breakdown of the problem. After that it's very simple basic equation solving. So let's explore this breakdown a little bit. Let's say we have something like this. Very simple, absolute value of x equals 3. Okay? Now we are looking for any and all values of x that we can plug in there that will make this thing work. Okay? Now remember, absolute value, by definition, is the distance a number is from 0. Okay? So if we have absolute value of 5, it's 5. Absolute value of negative 11, it's just an 11. Okay? What we have here is numbers that when we take its absolute value, we get a 3. Well, that would be a 3. Absolute value of 3 is 3. What else? Also, negative 3. Absolute value of negative 3 gives you a 3. Okay? So, this right here would be your solutions. Now, what I want you to also take out of this very simple example is kind of a structure within the problem. Okay? What I did to keep it very simple is I took this equation and I dropped the absolute value bars. Then I took this, I dropped the absolute value bars here, and then I changed the sign on that 3. Okay, so as these expressions get a little bit more complicated than this, we can always fall back on that general framework. Drop the bars, change the sign. Okay, let's look at something a little bit more complicated to see how that plays out. Let's say we have something like that. Okay? Now this isn't just, I'm going to look at it and boom, here's your answer. So what do we fall back on? I'm going to drop the bars, and then I create another scenario where I drop the bars and I change the sign. Okay? That is the important part of all these problems, is that initial breakdown into 2 separate scenarios, 2 separate equations. And now I just solved those equations. So I'm going to subtract 2 and then divide by 4. And we have x equals 1. Over there, I'm going to subtract a 2 and then divide by 4. And there we go. Now, you don't always have to check these, but I want to check this just so we can really see what's going on. Okay? If I plug a 1 in, 4 times 1 is 4, 4 plus 2 is 6, absolute value of 6 is 6. Now, look at where this came from. I found a 1 when this expression equals a 6, because then the absolute value of that 6 will give me the 6. If I go over here and I have a negative 2, 4 times negative 2 is negative 8. Negative 8 plus 2 is a negative 6. That's what I was looking for. Because when I take the absolute value of the negative 6, I get the positive 6. So it's the same basic concept of I want that positive and then the negative. It's just the expression has to be the positive 6 and the expression has to be a negative 6. Okay? So that's pretty much it. We're going to go over a few more examples, but there's really nothing else to this. Okay? Let me show you some more though, just in case there's a curveball or something that they may throw at you. Let's look at that. Now, the tricky part about this one is a lot of times you see a fraction in an equation and we say, okay, we have to eliminate that fraction, clear it. Not yet, okay? Before we do anything to this, we need to separate it so there's no more absolute value bars. So, just like before, I'm going to drop the bars, and then I'm going to drop the bars and change the sign. Okay? And now I solve those 2 equations. So I'm going to subtract a 4. I could clear fractions first, but I'm just doing it second. and then I'm going to multiply both sides by 3. There's one answer. The next one, I'm going to subtract a 4. And then I'm going to multiply both sides by 3. And there's my answers. That's all there is to it. Again, checking is a good idea, but it's not a necessity until we get later on in the section. I'll show you when it's really necessary. But when we have just a normal equation like this, checking is good, but it's not needed. Okay? Let's move on to another one. Now, this one's a little different. Why it's different is because we don't just have absolute value on one side and a number on the other. In order for this breakup to work, we need to have that situation going on. So first thing we need to always do is isolate the absolute value. So I'm going to subtract a 9. And now I have a very clean-cut absolute value equation where I can drop the bars, and then drop the bars, change the sign. Okay? And then I just solve each of those equations. So I would divide by 5, and then I would divide by 5. Notice I'm doing the same step, but I have two very different outcomes. Okay, so the solution steps are the same, outcomes will be different. And both of those are answers. Okay, sometimes we'll write our answers in a set builder, or I'm sorry, just a set, a collection of those two values like so. But if you just write x equals 2, x equals -2, for me, that's good enough. Okay, let's look at a few more. Each of these examples has its own kind of theme. The theme here is that 0. Now why is that something unique? Because we have the absolute value alone. If we go ahead and just kind of go through the motions, we would say drop the bars, change the sign. But -0, is there such a thing as a -0? No. So in this case, what is the only number that has an absolute value of 0? That's a 0. So even if this was a more complicated expression, if you have it equal to 0, all you do is drop the bars and solve from there. Okay? It's not that we have to have a second equation to solve when there's a 0 involved. Let's go on. Okay, so remember, first thing we got to do is isolate that absolute value. Okay, so I'm going to subtract a 20. And then divide by 3. Okay, now at this point, we will be dropping the bars, then drop the bars, change the sign. But here, don't even bother. In this case, our answer is simply no solution. If you write out the words no solution or do that empty set, either one will work. Now, why is that the case? We are asking in this situation, what number do I plug into x to make this true? To make this true, I have to take the absolute value on this side, and that needs to equal a negative. Will an absolute value ever equal a negative? No, it'll never happen. So in this case, once you have absolute value equaling a negative, boom, you're done. It's no solution. Now be careful though, because if let's say I give you something like this, okay, don't jump to no solution just yet, because we don't have absolute value equaling a negative. We have absolute value minus 5 equaling a negative. That could happen. It's only when you have that absolute value completely alone on one side and a negative on the other that you would say no solution. That's no longer happening here. Okay? So wait until you get to something like this or something like this before you make that distinction. Let's finish that one up while we have it up there. So I would drop the bars, and then drop the bars, change the sign. And I would subtract a 2, and then I would subtract a 2. And there we have our two answers. Okay? Let's look at 3 more examples, and that'll be it. See, we have this. Now, what's different about this one is that we have an absolute value on one side, but then we have a variable on the other side as well. Now, I want you to write this down before we get into this. Whenever you have a variable on both sides, you must check your answer, because there are times where we get an answer and it's just a bogus answer. We didn't do anything wrong, it's just a bogus answer. So whenever you have a variable on both sides, those you want to check before you move on. Okay? So, let's go through this though. Normally, what do? We first drop the bars. Then, we drop the bars, change the sign. Now, typically we change the sign on that number. But in a more general sense, we're changing the sign on that side. We're going to do the same thing here. The entire side needs to have that sign changed. Okay? Now, we solve these two equations. So I'm going to subtract a 2x. Then I'm going to subtract a 6. And then I'm going to divide by 3. There's one answer. The other side, I start by distributing the negative. Then I bring the variable on one side. Then I add the 3. And then I divide by 7. And there we have our answers. Now, again, before I move on to the next one, we need to check this, because I could have done everything right, and one of these answers is just a bogus answer. So let's see what happens. If I plug in a negative 3, 2 times negative 3 is negative 6, minus 3 is negative 9, absolute value is positive 9. So I'm going to write that down so I remember. I got a 9 on this side. 5 times negative 3 is negative 15, plus 6 is negative 9. Those aren't the same, okay? Typically when the answer is, when you did everything right but the answer was just bogus, typically what happens is you have something like this, where it's a negative on one side and a positive on the other. And in this case, that answer is gone, okay? Don't just assume that's correct. Let's check that as well. Okay, we got a fraction involved. That's okay. Just do your best with the calculation. So if you want, you can write it out. What do we have? We've got 2 times negative 3/7 minus 3. Okay, so that's that left side of the equation. Let's work it out. 2 times negative 3 is negative 6/7. Remember, if I want 3 in terms of sevenths, 3 times 7 is 21. So I have 21/7. That is a negative 27/7, and the absolute value is 27/7. That's this side. Let's go to the other side. Let me clean up the board a little bit. Over here I would have 5 times -3/7 plus 6. There's no absolute value bars on that side. So what I have is a -15/7. To change 6 in terms of sevenths, 6 times 7 is 42/7. -15 plus 42 is positive 27/7. Both of those sides work, or both of those sides are the same, therefore this answer works. The only answer we get is that -3/7. This is a good example to show, when you see something like this, which one did you probably expect was a bogus answer? You probably expected this one, okay? Sometimes the nice answers are the wrong answers, so we have to check, okay? It's not something we can just assume as we go through, okay? Let's look at a couple more to finish this up. Let's say we have these, okay? Now, this is different because we have absolute value on both sides. That does not change how you approach the problem, okay? So when you're doing this, we're going to treat it like we normally would. I'm going to drop the bars, and then I'm going to drop the bars and change the sign. I didn't treat it any differently, the fact that there were absolute value bars on each side. I still wanted those absolute value bars isolated on each side, but if they're on both, no big deal, okay? Now, the reason for that is, again, if these were to be the same, then with the absolute value, let's say this was an 8 and that was an 8. Let's say they're equal, okay, that's okay. Let's say this was an 8 and that's a -8. Those absolute value bars will make it true, so they can be opposites. It is not necessary to do another version where the negatives on this side and positives on this side, because we would just be repeating this, okay? So now we solve each of these, see what comes out. I'm going to subtract that x over, and then I'm going to add a 5. There we go. Over here, I'm going to distribute a negative. And then I'm going to add the 3x. Don't lose that negative on the 5. I'm going to add a 5. And then divide by 7. And there we have it. Now again, there is a variable on both sides. When the absolute value's on both sides, typically you're safe with the answers you get, but again, it's not a bad idea. Check it, okay? Just real quick, plug in a 10. We got 40 minus 5 is 35. Absolute value is 35. Let's write that down so we remember. And then I plug a 10 in here. 3 times 10 is 30, plus 5 is 35. Absolute value is 35. Let's go with a 0. 4 times 0 is 0. 0 minus 5 is -5. Absolute value is +5. 3 times 0 is 0. 0 plus 5 is 5. Absolute value, +5. Okay, so in both cases, it balanced on both sides. Both of those answers stay. Okay? So go one more. Now, again, we have absolute value bars on both sides. Don't treat it any differently. I'm going to drop the bars. and then I drop the bars and change the sign. And we've got that. Okay, now let's solve them. So this first one, I'm going to add the x over to get 2x plus 2 equals 4. Then I'm going to subtract a 2. And then I'm going to divide by 2. And there we go. The next one, I'm going to distribute that negative. And then watch what happens. When I bring this over, I get 2 equals negative 4. Is that ever going to work? No. So that right there, I don't even need to check anything with that. This will never happen. It will never be the case where this side is the opposite of that side. So that gives me no solution. That doesn't mean no solution is what I report for this initial problem though, because this scenario still had a solution and I need to check it. 1 plus 2 is 3, absolute value is 3. 4 minus 1 is 3, absolute value 3. So 1 is my answer. This whole thing just didn't have a solution to begin with. Okay? So again, very, very simple setup. We just need to know that that's how we set it up. Drop the bars, change the sign. Just keep true to that. Be careful with your algebra, and you'll do great. As always, work hard. Let me know if you have any questions, and I'll see you next time.